Okay, this is a video recording of lesson 12 titled Unit Testing. Unit testing tools are one of the many tools we have to help us produce software that is functioning more correctly and with less bugs. Of course, unit testing tools or any type of testing tool is not a guarantee that your software is bug-free, but it's a way, one of the ways we can use to help identify bugs or issues in our software and reduce the total number of them. So, assuming there's not an infinite number of bugs. Um, So at the beginning of the course, I showed this diagram here. This is the DevOps or development operations diagram, and it shows us, in the perfect world, the workflow or the life cycle a software development team should go through to produce high quality software. And so we have the plan phase where you get an idea and you define requirements for your software, and then the code phase, you write the code. We've been living in the code phase most of this course. There's the build phase. We saw a little bit about the build phase when we click the run button or the build button in Visual Studio, that it took our source code, our C# code, and compiled it into binary code and placed that binary code into the DLL file, and that's what the that's what Visual Studio was running, or the computer was running to execute our program. It's worth mentioning that in our class, the build step is relatively simple, and usually we just have to click play in Visual Studio. But in larger software projects and in different programming environments, the build step could be a lot more complex. But for us, it's pretty simple. And now we're moving to this testing phase. Of course, it's good to produce software that is reliable and accurate and containing few bugs. So that's what this testing phase is all about, is things we can do as a development team to help ensure we have high quality software. And then after we do testing, that'll be this lesson, and the next lesson we'll talk about deploying our software, and operate and monitor. I'm not sure we'll get to in this course, but that's the life cycle, and then and you rinse and repeat, right? This is an ongoing thing that a team has to continually and iteratively do to support software. So, okay, so also at the beginning of this course, I showed this diagram of these different development roles, and we talked about the software programmer role. We talked about the business data analyst role. We could talk about both of these roles until the end of time, but for the purposes of this course, we're going to kind of say we're done there, and we're going to talk about the software testing role, or QA for short, which is short for quality assurance. And of course, just because there's these different roles doesn't mean there's necessarily different people doing these roles. So if you are working for a company that writes software for airplanes or something like that, then it's probably going to be different people in each of these roles. It'll probably be really important that you have different people who test the software versus who develop the software, right? That's if different people are trying to break holes in your airplane software, that's going to they're going to find more issues and more bugs than if the people who wrote the software were trying to test it. So that kind of separation can be really important in certain development contexts. And then on the flip side, think about small companies who maybe only have one or two developers, or graduate students who kind of need to do all of these roles, right? They need to do everything. They need to develop software, test software, They need to figure out what to do in the first place. They need to be a product owner, deploy it, and be analytical about things and so forth. So just because there's different roles doesn't always mean there's different people, but sometimes there is different people because sometimes that's a good idea. Okay. Anyway, this we're going to split this software tester role, this QA role, into two different roles. These diagrams, they make the world look cleaner than it is. It's not this clean, but I think for teaching purposes, it'll make sense to split these up. So today we're going to talk about a unit tester, and then lesson 13 we're just kind of going to smash together all other forms of software testing. Not all other forms, but a lot of other forms of software testing. Okay, so from the perspective of our unit tester, the world is much simpler, right? I mean, a unit tester works directly with C# code to ensure that given pieces of code work as we expect them to work. And so the unit tester has to have knowledge of C# and know how to write it, and they also need to be able to get the C# from their version control system. So in our case, that's Git and that's Azure DevOps and the repo section. They have to be able to get code to their machine so they can test it. And of course, they're going to want Visual Studio to review that code in and write their code in. So unit testers also write code. A debugger is always helpful for testing. And the tool we're going to look at this is a unit testing tool, a unit testing framework, you might hear it called. There's many of these out there. The one we're going to use is MSTest because it comes with Visual Studio. But there's a lot of great ones out there. There's a unit testing tool called JUnit. I think there's one called XUnit. There's some kind of other testing frameworks that kind of sit in proximity to those. So one I'm thinking of is Mock. So anyway, a lot of unit testing tools, but we're just going to talk about MSTest to kind of introduce what unit testing is. So to introduce the topic, let's think back to homework 1. We had this code here. This was the assigned to house method that was located on the student object for the Hogwarts sorting hat. And, we had some criteria and, based on some conditions or some state of our object, we assigned the student to a given house. And so hopefully by this point in the course, the reasoning about this code is pretty straightforward, and hopefully you could just reason about it to assert that this code probably produces the correct result. Of course, if you weren't confident in that, you could build an app around it and test it by creating some council application interface and creating new students and then entering criteria and then seeing what house they get assigned to. So, really the only way we could test it was building an app. And with unit testing, that's going to change. So let's look at a harder example. So this is a method, a static method that calculates a number in the Fibonacci sequence. So if you're not familiar, the Fibonacci sequence is defined as, it's an infinite sequence, but it's defined as the first value, or the value at index 0 is 0, the value at index 1 is 1, and then every value after that is defined as the sum of the previous two values. So 0 plus 1 is 1, and then 1 plus 1 is 2, 1 plus 2 is 3, and then here in index 5, 2 plus 3 is 5, and then so on. So that's how the Fibonacci sequence is defined. Say we wanted to write a method that calculates, index 50 of the Fibonacci sequence. Our method might look something like this, and if you're familiar with recursion, then you could probably reason that this will work. But if you're not, how do you really know that this is going to produce the correct Fibonacci number, at index 7,029, right? And there's kind of two options here, right? Write a inductive proof or build an app that allows a user to look for some index and produce the result and compare that result to what you know to be correct. So both these options are too much work. Writing an inductive proof is going to be too much work from our perspective, and building an app to do this is not, that's not a useful app, one that just calculates the Fibonacci number, especially because you can just look online and there's already something out there that will do it for you. So how do we want to test that our calculate Fibonacci number is correct? With unit tests, right? As you might expect by now. Okay, so let's define the term unit. So a unit is defined as the smallest piece of code that can be logically isolated in a system. And I took this definition from somewhere, but it makes sense to me, and I think it works. So we'll use it here for our course. Smallest piece of code that can be logically isolated in a system. And for our purposes, in this course, a unit usually equates to a single method. But of course, methods are not always accessible in the same way. So on the left here, we have a cookie jar class, and this has 1, 2, 3, 4, 5 methods. But you can't actually use these methods until you create a new cookie jar object, and then set it up, and then get it in the correct state, and then you can call the method. On the contrary, we also have these static methods, which you can call much more easily. You can just say, so this is an extension method, so you can just say, some list dot to delimited list and pass it in. So these are a little bit more accessible, take a little less setup. Although, yeah, maybe this one on the right isn't the best example, but you get the idea. Some methods are easier to call than others. Okay, so if a unit is the smallest piece of code that can be logically isolated in a system, then a unit test is obviously going to be the code that tests our code, a code that tests our units, we could say. And in particular, what we want to test is, given a certain input and or state, does our unit produce the correct result? Okay, given a certain input and or state. Okay, so we'll talk about what we mean by state there, but here's a simple example. So our input is a grocery list. So you have my grocery list, right, and some data in there, and you call your toDelimitedList method, and that there's a code for it there, but you call toDelimitedList, and your result is stored in the delimited-list variable. And if you were to print that out to the console or whatever, we're able to assess, is this the correct result based on this input, right? Pretty straightforward, pretty simple, but that's a unit test. Okay, so as I alluded to a few slides ago, not all methods are accessible in the same way or are called in the same way. And we have some methods or some units that are dependent on input only. So typically these are your static methods or your extension methods. So for example, we wrote the between method in the previous lesson, and you'll see it has inputs, right? 3 integer inputs, and based on these inputs, it returns some output. So this is a unit that is dependent on input only. So that's one type of unit we'll need to test, dependent on input only. But we also have units that are dependent on state only. So these are typically going to be your object methods, things you have to, classes that you have to create new objects for to actually call the methods. So our object methods that have no parameters. These tend to be dependent on state only. So assign to house is a good example of that. Our student object holds some data, it has some state. So last name, jelly bean, favorite jelly bean, first name, birth date. It has this data that's part of it, and then it also has this method that takes in no parameters, and that's what it uses to perform its calculation, to do its thing. Okay, so units that are dependent on state only. And then, of course, we have both, right? We have some units that are both dependent on input and on state. And a good example of this is our cookie count by type method. So we have input, we have the type the user is looking for, and the result of this method is not only dependent on what type gets passed in to the method, but it's also dependent on the current state of the jar. So, what cookies are in the jar at the time this method gets called will change the result that it returns. Okay, so dependent on both input and state. And kind of as a side note, some people wrote check cookie count by type with something like this here, where the method goes out to the user to get the type and then performs the calculation and then prints that out directly. And what you might observe here is that this is not going to be easily testable, right? Because it doesn't return any results. It just prints to the console. It's probably not impossible to test this, but it'll be much easier to test if we can say, given this input in this state, we expect some output. Okay, so this is not as easily testable. Okay, so let's talk more about those results. So the result of a call to a method is usually either going to be a return value, a value that the method returns, or an update to the state of an object. So assign to house is an example of the latter there. So you call assign to house, and it will update the house property on a student object. So we say the test result is an update to state. And cookie count by type, for example, is you call it with some input, and it's dependent on the internal state, but the result of calling that method is simply a return value. It returns a double or whatever it does. So I don't know why it returns a double instead of an integer. But anyway, so those are two different types of test results we have. Okay, there's one more situation we'll want to think about both as programmers and as unit testers that will illustrate here with this between method example. So say, for example, we have our between method from the previous lesson, and someone called the between method with the larger value being passed in as the min value and the smaller value being passed in as the max value. So if someone did this, you can see the logic we have here will not work. Okay, this will not work if these are flipped. So there's two things we could do as the programmer of this method. And the first one is just swap the values, right? So just if min is greater than max, flip min and max, and then execute this same logic. So we could do that within this method. The second thing, which is what we're going to do for the sake of talking about another type of test result, is throw an exception to signal an incorrect usage. So let's see what that looks like. So if this method was called, with the larger number as the min value, we add this check in our between method code that throws an exception. And that means if someone writes this code here, some number between 10 and 1, you will see Visual Studio will freeze and say there's an exception and it hasn't been handled, and for that reason, we're going to crash the program. The program is going to crash. So that is something we might want to do to let people know they're using our code incorrectly. Okay, so back to unit testing. This could be another result we want to assert that happens. We want to verify that if something is called incorrectly, our method correctly says the caller called it incorrectly. It correctly throws an exception to notify the caller that they used it incorrectly. So that is another test result we'll want to verify. Okay, so now let's get into some examples of some unit tests. So how your unit tests look will vary depending on the unit testing framework you're using. We're using MSTest again, but hopefully, the idea of writing unit tests and is transferable no matter which unit testing framework you're using. I mean, even if you're switching from C# to Java or Python or to some other language, because you wrote unit tests in MSTest, it should be transferable. Writing those unit tests in those other development environments with a whole different tool set. Okay, so this is what it looks like in MSTest, a unit test, and there's no new C# syntax here, right? We have some attributes. We talked about attributes. We have a class that it's called extension method tests, and then we have a method here. Method has a name. We'll talk about how we arrive to this name for our method, and it has some code here. So no new C#. Okay, so now we'll break down how we arrived to this name for our unit test method. Of course, how we name things is important in this course, and it's important in software development to follow naming conventions and so on. And so we're going to use the naming convention recommended by Microsoft for MSTest. If you're using something that's other than MSTest, Microsoft might recommend a different naming convention. I don't even use this naming convention in my own unit tests, but we're going to use it because it's good to pick some convention and stick to it. So we're gonna stick to the default Microsoft naming recommendation for MSTest. Okay, so let's break it down. Part one is the name of the method we are testing. So if we're writing a unit test for toDelimitedList, which is what we're doing here, then the name starts with toDelimitedList. The scenario being tested, so the scenario here, given a normal list, right? That given normal list, that describes the situation we're in when we're testing it. And then part 3 should state the expected resulting behavior. So if we call toDelimitedList with a normal list, it should return a correctly delimited list, right? Pretty kind of formulaic in how you develop this name here. So that's how we get to the name. Okay, yeah, another example of naming. So say we were, you can tell kind of exactly what this code is testing just by the name. So if we're testing the assignedToHouse method and given a Weasley to the assignedToHouse method, the house that should be placed on the student object is Gryffindor. Okay, so that's, we arrive to these names, following, these three steps here. Okay. Let's talk about writing the test, okay? So 3 parts to writing the test method, and we have a phrase here, triple A. The 3 steps are arrange, act, and assert. So first step, arrange your objects, creating and setting them up as necessary, right? And this is kind of gets back to what we said about some methods require a little more setup to test than other methods. So you have to create a new student object before you can call assign a house. So that's the setup. That is the arranging. Act is the actual call to the method, and then assert is the step you take to confirm to confirm that the result of your action matches your expectation. Okay, so here it is laid out here in our unit test. So we arrange, so we have to set up the student object, and not only do we have to create a new student object, we have to give it some state, and then we call, and then our result is confirmed in this assert statement. So I've split this variable out that holds our expectations. Our expectation is Gryffindor, and we assert that the expected house matches the house that is assigned to our A. Weasley object. Okay, so that's the formula there. That's the pattern we follow when writing unit tests. Yeah. Okay. Yeah. Some animations here. Okay, a few more notes here. So to be able to write unit tests, or the place you keep your unit tests, I should say, is in a MSTest project. So we've seen we can make council application projects, and we've seen that we can make class library projects, and now there's a new project type that will be involved in our C# solution, and that's the MSTest project type. So here's an example of what that looks like in the Solution Explorer. So we have the Council app project, and we have our class library project, Common Code, and then now to test Common Code, we have a MSTest project that houses the unit tests that test the thing we want to test. Okay, so just a new project type in Visual Studio, and we'll see that in the exercise. And I guess one more thing to note, which we'll also see in the exercise, is to when you create the Common Code tests project, I mean, first you have to create the project, but then you also have to add a reference to the project that you're testing. So there'll be a reference added from Common Code tests to Common Code. Okay. And then last thing is about test runners. So a unit testing framework such as MSTest should come with a test runner, and the test runner provides a nice graphical interface that enables you to run or debug tests and look at the test results and so on. So here's our example here. So this is the MSTest test runner, and we can see with this that there's 2 unit tests total, and there is 1 passing test, and there's 1 failing test. And we could run all tests with this run all button. We can run an individual test with this one. We can also right click on this stuff to either run or debug a given test, and just view a summary of how our tests are looking. So and of course the reason we're using MSTest is because the test runner for it comes with Visual Studio. It's built right into Visual Studio. If we used a different unit testing framework, we'd have to maybe take some installation steps to get some way to run our tests. But that's the test runner, and we'll see this all in the exercise. Okay, so now we'll begin the lesson 12 exercise. The exercise is fairly straightforward. We will clone some starting code, and the starting code is just various code that we've written through previous lessons in this course or previous homework assignments. So I have that repository cloned here in Visual Studio, and there's no actual apps in here. These are just class libraries, and actually I need to update a few of these. So yes, this one's targeting an old version of .NET, so I'm going to update that. And this one's also doing that. So I'm going to the property. I'm right-clicking on the project, clicking properties, and then in application general, I'm upgrading it to a newer version of .NET. Okay. So with that, let's see what the exercise wants us to test. So in the Common Code class library, we want to write unit tests for calculate word count and two tests, one with a well-formatted string and then another with a poorly formatted string. So let's do that. So let's right-click on the solution level and do add new project. And then we want to search for a new type of project, MSTest. Yep, this is the one we want here, MSTest, test project. And I'm going to call it tests.commonCode. Okay. Okay, good. And it nicely generates an example test class for me here. But what I'm going to need to do here now is add in dependencies. I'm going to right-click dependencies, add project reference, and then common code. Okay. Okay, so let's rename this. So I'm going to do Control RR and rename this to extension method tests. And then now we want to name this method. So we're testing the calculate word count method, and the scenario we're testing is a given a well formatted string correctly calculates word count. Okay, good. Okay, so our first step is to arrange. So we calculate word count is dependent on input only, and that input is a string. So let's prepare that string, arrange that string. Equals fox jumped over the moon, something like that. Okay. So we arrange and we act. So to act, we do. So I'm gonna create a variable called actual result. Like that's what our calculate word count returns, an integer. So int actual result equals some string dot calculate word count. Oh, good. And Visual Studio added the reference up there for me. And then assert is our last step. And what I'm going to do here is I'm going to create another variable called expected result just to be explicit in this. And so we expect, given this string and this method call, the result should be 1, 2, 3, 4, 5, 6. Okay, so our expected result is 6, and then now we can do the assertion. And yeah, here we go. So the expected result matches the actual result. Okay, so let's open the test explorer. So if you don't see, let me close this. If you don't see the test explorer over here, go to view up top and do test explorer, and then you get it back. Okay, so here's our test. We can see it in our test explorer. The name we provided, our method, is showing here, and then the class that it's encapsulated in, and then so on. So if we do run all, it should pick up this test. Hopefully. There it is. Good. And so let's do the other one now. So the other one is if the string is poorly formatted. So this is a different scenario. So I'm just gonna pick this code up. Right, and these attributes are important. These attributes are how the test runner knows that this method is a unit test rather than just some other type of method. If we're given a poorly formatted string. Yeah, okay. Poorly formatted string. Okay. And you'll see that method pops up right here in the test runner. The test runner sees that you've added a new unit test. And if you were to delete this attribute, it's gone, right? Now it's just a normal method. Okay, so put that back. And this is what we did last time too. We added some spaces to this, and the implementation of calculate word count. If we jump over to that, you'll see it's not handling the situation, or it's not the code that handles this situation. So if we were to run this test, and we can right click right on this test and run it. You'll see it fails, and you can click on this here, and this window gets kind of small, but you can see that the assertion failed. We expected a result of 6, and our actual result was 16. Okay, so now to get this test to pass, right, the fact that this is failing, it notes that we should probably update our implementation to handle this scenario. So to do that, we can do exactly what we did last time. So string split options, remove empty entries. Okay, so the implementation's updated, and we can run it. Good, and now that passes, and we can run all, and all tests should pass. You'll notice that I renamed this class, the default class name, which was unit test 1, with the control RR, but it didn't update the file name, so I guess I'm going to do that manually. So I'm going to go over here, and I can just rename like that. It's good. It's generally common that your file name here matches your class name that the file contains, and that's actually required in Java. So, okay, so we're good. We've tested this method, and we'll hop over to the other one. So, test that between is inclusive. Okay, so that's if we look at our between method, we can see with this logic, between is inclusive, and kind of what we're getting at with this test is tests are not only good for ensuring your code works, but they're a good form of documentation. So the fact that we have a test that's checking if is between is inclusive documents that is between is supposed to be inclusive. That's how we expect it to behave. in our application or in our software or our class library or wherever. Okay, so we make this test method public void. Yeah, all of these are void. Uh, um, is between given two numbers or no, really, so given edge case number um, uh, result is true. Okay. And we arrange, so let's give this 10 and we act equals some number apparently it's just called between in this version of the code. Okay. Between some number between 1 and 10. So if 10 between 1 and 10 is between 1 and 10, assuming that we've implemented this to be inclusive. So then we assert, and our expected result is true, and assert that our expected result matches our actual result. Okay. And if we wanted to, there's also, so R equal works, but there's also an is true method, so we can just verify that our expected result, yeah, we could do it like this, essentially. No, we can do it like this. Yeah. Okay, same thing, just kind of another static method available on the assert class. So now let's try this out. Okay, so that's good. And then our last common code test is that when min value is greater than max value, we want to validate that an exception is thrown. Okay, so the scenario is given min value greater than max value, result is exception is thrown. Okay, so essentially if we do this, it should throw an exception. And let's see if we can assert dot. Okay, yeah, so this is interesting. Yep. So assert throws exception takes in the term anonymous function is going to come back. It takes in a function that does something, and what this assert method is going to do is essentially say, well, when I call the anonymous function that you described here, the result of that should be an exception thrown. So, right, because if we just do this here, that it's just going to error, and our assert is not going to run. Well, yeah, I mean, that's eventually what will happen. So our anonymous function is going to come back, and yeah. So we kind of gotta melt things together here. So throws exception. No, why doesn't it like that? Type. Okay, so I'm not sure why that doesn't work. So let's do something like MSTest assert exception. Oh, there we go. That's why. So it wants to know what type of exception you expect, right? There's a lot of different types of exceptions: index out of bounds, argument exceptions, invalid operation exceptions, no object not sent. Null pointer exception, right? You might have seen that message. Object reference not set to an instance of an object. That's a null pointer exception. So there's a lot of different types of exceptions, and the one we want in this case is going to be an argument exception, meaning these arguments or these parameters were sent in an invalid way. Okay, good. So if we run this, this test is going to fail because it does not throw an exception. If we review the between implementation, it does not throw an exception. So now to make this test pass, we just have to do that check if min value is greater than max value. Throw new argument exception, min value must be, hold on, let me actually, wait, min value must be less than or equal to max value. Okay. Good. And so now let's run this test again. And we're good. It correctly throws that exception. And so if I put another exception here, I don't know, like file not found exception, right? Some other exception, and we run this. It's not going to work. And you'll see in this message here, well, you'll have to kind of dig in a little bit, but it'll say, we expected a file not found exception to be thrown, but an argument exception is thrown. So that's what that's saying there. So we can put this back and run all. Okay, so that's it for the common code test. Let's do the sorting hat test. So it should be a pretty simple test, I think. Test that students with the birth year 1926 get placed in Slytherin. So these, so I'm gonna create the new MSTest project, add, new project, MSTest project, and we can go test.sorting hat tests. Okay. Okay. Sorting hat tests. Rename this. This is student tests. And the interesting part about this is that these tests are all static methods that are dependent on input only, and this test is, as we saw on the slides, is also dependent on the state of an object. I mean, that's solely what it's dependent on, and the result is the result is not a return value. The result is an update to the state of that object. Okay, so the thing we're testing, the method we're testing, is assigned to house. Assigned to house when given birth date. When given 1926 birth year, house is Slytherin. Okay. Yep. Dude. Of course, we gotta add a reference to the sorting hat classes project. There's another way you can do this. So I right-clicked on the dependencies last time, but you can also click on the error. And sometimes this works, sometimes it doesn't, but you can do control dot, and then it'll suggest add reference to sorting hat classes. And that's exactly what I want to do. And it adds the reference in here, and it also adds that using on top. Okay. Student equals new student, and right. So our range step here, student dot it's year first. 1926. Yeah, something like that. Okay. We act, and then we assert. Okay, so what we're asserting here is that our expected result is equal to Slytherin, and then we assert that the expected result is student.house matches the expected result. Okay, there we go. So this is what this test could look like, and okay. Test did not pass. Why is that? Oh, there's that object reference not set to an instance of object. How is that possible? Um, so when in doubt, we can right click and go debug, and it should hit the debugger right here. Oh, that's right. Okay. Yep. It doesn't like that jelly bean is empty, but we're trying to call, or is null. Jelly bean is null, but we're trying to call two upper on it. So we could fix this in the code if we here. Let's do it this way. So what this question mark is doing here is saying if the jelly bean happens to be null, we can't execute two upper on something that's null. If it happens to be null, don't call two upper. Just say it's null. Just all this should just be null in this case. So this question mark will handle that scenario for us. We could also have added a jelly bean here, and that would have made the error go away. So, but to illustrate that working, let's go ahead and run it. Okay, and now we're passing. And so here's our unit test that tests this scenario, but this scenario is actually not, this isn't something that's always true. It's not always true that if you have a birth year of 1926, you will be put in Slytherin. That's true in the case of this test, so the test is even more specialized than the name we're giving it here, because this will not be true if you do this, right? Based on kind of our criteria. Right, so just something to keep in mind when doing this. Okay, and let's knock out these last two. So this is from the lesson 7 exercise that we made up on the spot. This is the PlayStation class, and we want to test that if the PlayStation is on and we load a game, the current game is equal to the game we loaded. If the PlayStation is off and we try to load a game, an exception is thrown. Okay, so let's go ahead and do those two tests. So we'll add new project, MSTest. Okay. So this is the load game method, I believe. Okay. Yes. Load game. Okay, so this is an example of a unit that is dependent on both input and on the state of the object. So load game, when on and game loaded, the current game matches the loaded game. Something like this. So to arrange, we create a new PlayStation. And control dot. Come on. Control dot. All right, I guess we'll do it this way. Add project ref. Nope, wrong one. Add project reference to the PlayStation code. And using PlayStation code. Really? How did that happen? Okay, well that's wacky. All right, yeah, that fixes it. I won't worry too much about that. So we arrange, we have the council. In this scenario, we also need to turn on. This changes the state of our council. And then we act. We just do console dot load game. We'll do it like this. We'll do PlayStation game. Metal Gear Solid, is that one? Metal Gear Solid? I think that's a PlayStation exclusive. Okay. And assert. So now we're going to assert that the game to load matches the console.current game. Okay, there we go. Let's run that. Okay, good. That seems to be working. And then the last one here is test that if the PlayStation is off and we try to load a game, an exception is thrown. So copy this here. Make sure it's off. And exception is thrown. So as we did last time with it, we're going to kind of combine the act and the assert. And the type of exception we would want in this situation is an invalid operation exception, which essentially says that you tried to perform some action on some object, but the object was not in a valid state for this action to be performed. Okay, and then we'll do exactly what we did before. We're creating an anonymous function here that calls the thing that will throw the exception, which is essentially this code here. Okay, and we'll run it, and it should, maybe it fails. Okay, yep, it fails. And so now we whoa, okay, here we go. And now we just add that logic if power status doesn't equal on, then there we go. Okay, and that's it. So we got 7 unit tests in here, kind of covering a different range of scenarios. Of course, there's more scenarios on top of this. But from here, we're going to do some kind of auxiliary activities here. So the first one is installing a third-party library called Fluent Assertions that kind of allows us to write our assert statement in a different way. So this should be pretty simple. So I'm going to close all these tabs, and I'm just going to go to the common code test, and I'm going to manage NuGet packages, and we will install Fluent Assertions. Okay. And what that allows us to do, or what this library does, is now we can do something like actual results dot should be expected result, right? And then we don't need this anymore, right? So this is what our assertion looks like. So it doesn't work any differently. It's just gives us kind of a fluent syntax. It reads a little more like natural language. And we can, so actual result should be and then let's try this one here. So actual result should be true. Look at that. So it figured out that because actual result is of type Boolean, then be true should be a method on this here. But what I suspect is if we looked here, yeah, be true is not going to show up because our actual result is of type int, so it doesn't make sense to say an int should be true. Okay, and then let's see how this one looks. I actually don't remember. Oh, fascinating. Okay. So as we said, well, I think even this might work. All right, maybe not. I think we can do this. The thing to do equals new action. And then when we do, so thing to do should throw a argument exception. Okay, so we still have our anonymous function, but it's actually contained by an action object, where an action is just a function that will be executed at some point. So, so at this point, the action has not been executed. It's just setting up, saying this is an action that we could execute in the future, and that's what should throw is probably doing. So. If we did, it won't actually be executed until you go like that. Then it says, okay, well now I'm going to look at the action I've been set up to execute, and now I'll execute it as soon as you put these parentheses after there. But here we're just saying what we want to do, and it's actually done when you do this step, but that's what should throw is also going to do under the hood. So let's see if this works. Okay. Yep. Seems to work. Okay, so just another way to write these assertions that kind of follows this notion we've been talking about of something reading fluently in code. Okay, so now last little auxiliary exercise here is we want to clone the same repository we cloned last time in Visual Studio. So to do that, I will close solution. And I already have it cloned, of course, so I'm just going to open it. And I just wanted to show the unit test in here. And this will be more interesting. So I can run this app on my machine that I'm recording on right now. But in the lab, I'm not actually going to be able to run this app because there's a bunch of setup that needs to be done. I won't be able to run any of the apps in here. This one, and this one. I won't be able to run those in the lab because a database needs to be set up and it needs to be configured to connect to some database and all of that. So the app doesn't run in the lab. But despite that, we can still run all of our unit tests even though the app doesn't run. The app, yeah. So let's see that happen. Okay, it's running. Okay, good. So it ran, there's 52 unit tests. It ran them, 46 passed, and 6 failed. So this is just a demonstration that you can do this. And the important point here is that because unit tests are picking out and targeting little pieces of isolated code, we don't need a fully functioning app to be able to write unit tests. So That's a great property about unit tests. You can test your code early and before maybe your whole app is set up and running. So that's one great advantage of doing unit tests. So okay, that is it for lesson 12.